Moving on. I will say she ruined the all right, hold on. That's actually what I need. I waited all day for what last night? What did I wait for? Everyone knows. The Star Wars trailer. So that's a halftime. And then it comes on, and I don't sit down. I'm standing up, and I'm just watching it, and she's sitting next to me. And then after it's done, she makes a sarcastic comment. Was that like the greatest thing you ever seen? I'm like, why would you ruin that for me? So that's... So math. 3-6. So we're actually going to solve equations, but this is a weird little formula, and I'm going to give you 4. This one I don't think would be a problem too much to memorize. And the next 3, definitely not. And actually, the next 3 I'm going to show you, you really only need 2 of the 3. But this one stands out on its own. This is Newton's law of cooling. Very simple. I boil some water. I take it off the heat. What's the water going to do? Cool down. Why? Why is it going to cool down? Because you took it off the heat, which was hot, and put it in an area that is what? Cooler than what that water is. This is Newton's law of cooling. It actually could be Newton's law of heating as well. Because what happens when I take an ice cube out of a freezer and I put it in a room? What does the ice cube do? Well, it melts because its temperature what? The temperature goes up because of the surrounding temperature. So it works both ways. So if you look at this formula, which we're not going to, derive it. I won't even know how. Just know the parts. T of T is, big T is temperature over little t time. And it's usually in minutes. It could be in seconds. It really depends in the word problem what they denote happens. And then T of M, that's the temperature of the air or the surrounding area of so the water taken off the heat is the room temperature. If you take boiling water and put it in snow outside, it's obviously going to cool off quicker than if you take it out and put it in a 98-degree room. So the surrounding temperature does matter. Plus T sub 0, which is original, and then you see all the rest. Now, I will mention this. In Newton's law of cooling, your temperature will be going which way? Which way will your temperature be going for the water? Down. So look at what's in there, and I think it bears making this point. The negative is already built in because that's a rate, the rate that this is changing at. So the negative is already built in. So when we actually do this first question, K will come up as a positive. But why? Because the negative is already built in. So be aware of that. If I took an ice cube and I put it out in room temperature, when you do your math, you get K as a negative. But why? What's a negative negative? So it's really a rate of increase per hour in the ice cube example. So be careful in that. It's a little semantic. I don't know why they build it in. I think they could have it without it. But we're just going to leave it as is. All right, and then try to read this question with the formula still in its place. Or so you can... So the reason that line is there, I don't think I said that online, but on the movie, whatever it's called, student got it too, that there's 2 parts to this, and you have to do the first sentence before you can even go on to the second sentence. So that's what you do. All right, and then not to bore you, I think you can know how to do this, but I do have to have the formula showing so you know where everything goes. Does T of T exist in this first sentence? Is it a number? And if so, what number is it? What number is the temperature after time that I'm looking for in the first sentence? I was hoping people would say it out loud. 45 equals, I'm not sure what these underlines here for. I'm not sure I'm going to get that to actually do anything. But then do I have T sub M? What's the temperature of the surrounding medium? 16, because we're putting in cold water. Now, let's talk about what happens realistically. You put a hot egg in that 16-degree water, what actually happens between the two? They start meeting, someone had a great word, equilibrium. The water gets warmer as the egg gets colder, then eventually if you leave it in long enough, they're going to be equal. All right, and then the room temperature takes over in a third. We're not doing that, all right, so don't overthink it. But that's the realistic thing of it. Plus, and then what's T sub 0? 96, and then T sub M we already said. And then it's E raised to the negative K what? 4. 4 is the time, and now that denotes that time is in minutes for this question. All right, and that's all we got to say about that. Sometimes they say, like you can use Newton's law of cooling. I love watching Columbo. Anyone know what Columbo is? And actually just had an instance yesterday where 2 women murdered a guy. All right, but then they murdered a guy and then they put a heated blanket on him. You want to know why? Why did they put a heated blanket on him? I feel like I'm teaching something terrible to the students, but do you know why? So they don't know when he died because they controlled the temperature of the body by keeping it warm. Then they tried to pretend the murder happened 2 hours later. But that's Newton's law of cooling. They actually have a Newton's law of cooling idea, at least a little bit, for determining when a body has actually passed away. What am I teaching the kids? All right, a lot of weird stuff in this video. Okay, now, you know what's not hard about this? If you are a PEMDAS pro, you will never make a mistake. But that's, when I teach this 2 years ago, this was jacked up so bad. Students could, well, actually, part of the problem is not knowing where the numbers go. That is a big problem. But the second thing is PEMDAS. What do I have to do first? I know I'm solving, but I actually have to simplify using PEMDAS. So it's 80. Then we'll talk about those crazy kids that do the silly mistakes. I constantly have people taking 16 and adding it to 80. Redonkulous. If this was a number, then they try to multiply these two. Can't do it. You take care of exponents before you multiply. So since I can't add and I can't multiply, what do I do with those two numbers? Subtract and then what? Subtract 16. Come on, folks. Pretend there's this class in here. And then what? Divide. And then guess what you done did? You just got this ready for... And then I'm not even going to worry about that decimal. As a fact or a fact, there is no rounding here. There is storing. You're going to store these values that you get. So log base who? Log base who? E of who? 29/80ths. I heard that over there. What's log base E? ln. And then what am I going to do with that answer off to the left? I'm going to divide it by what? -4. So I'll stop the movie and I'll get my calculator ready. So what kind of rate did we get here? We got a what kind of rate? Positive. But why? Because in the formula, the what is built in? The negative. So this is a decreasing. As a Federmac, this means 25.3, don't ever round, 6 ... percent what? Percent decrease per what? Per minute. Okay, because that's what that percent actually ends up doing. Okay? All right, now what we need to do is actually plug that back into our formula. All right, and I'll try to speed this up. I'll do that offline. But we're going to rewrite this to now proceed on to the next one. And it didn't take long. I'm taking a long time to explain it. You're not going to take long on these. You're going to stick the numbers in, simplify, and then solve, and then go ahead and replug it in. But to determine when the egg will be 20 degrees Celsius, go back to the original. Okay, don't go from the, so back to the original. When will it from 96 turn into 20? So basically you turn 45 into 20 and you go from there. So the original medium was 16 in the water, and then it originally was at 96 degrees. And then now we plug in E raised to the negative 0.25 blah 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 t, because in my calculator I'm going to go ahead and store that in for x. No rounding. When you round this stuff, you'd really jack up Newton's law of cooling. Remember how ridiculous rounding could be. I could literally take that and round it to 0.3. You're going to be way off on your minutes then. When you get into exponential scenarios, rounding is destructive. And you got to be aware of that. Okay, then we'll do the rest offline and show you. Okay, so I'm not even going to worry about rounding this. Not going to do it. Okay? And then I'm going to change this to a logarithm. And then what does that mean I'm going to have to do when I'm done? After I ln 4 over 80, what am I going to have to do after that? Divide by? And guess what? I have that stored in my calculator now. So all I have to do is ln 4 divided by 80. I don't even care about rounding. because I don't really need to solve this question, divided by my stored x. What did I do wrong? I did. What a maroon. I didn't put the negative in there. Okay, so that was supposed to be divided by negative 0.25. So 11.81 what? Minutes that it takes for this to happen. Whew. Okay. Here's the next three formulas, which the students promised they saw this last year. So actually, you really only need these two. And then when I talked about this last year, that's why I have this one crossed off, and I'll tell you why after I explain this. I asked those who had a savings account. How many people have a savings account? All right, I'm sure you're making massive interest, like 0.05% per year or something like that, or maybe 1% per year. Let's pretend you're making 5% a year. How many people look at their statements? Raise your hand. You get them in the mail and you look at them. How often do you get them? Do you know?
Like 6 months.
Every 6 months. So you know what he gets his interest paid? Semi-annually. Anyone else get something better than that? Not better, but different. What if you got it every 3 months? What would that be? Quarter. What if you got it every 12 times a month? That would be what? Monthly. All right? So on and so forth. Usually when you get those statements, you're given an interest payment. Okay, and I'll zoom in on those that are trying to stretch their necks to see this. Okay, so let's zoom in on this one. This is the savings account where you get one interest payment at the end of the year. Nothing special. So let's say you have $100 and you get 5% per year and paid at the end of the year. How much do you have at the end of a year? 105. Very simple. But let's say you have a bank account where they say, you know what? We're going to give you 5% per year, but we're going to compound that quarterly. That doesn't mean you get 5% per quarter. That would be ridiculous, and if you do see a scenario like that, run to that bank and invest your money immediately, because that's a lot of money. But what it means is you get 5% divided by 4, so you get 1/4 of 5% after 3 months. Now, we can figure out what that would be. It's very simple. It's 1/4 of $5. But what you get is that money in your account after 3 months. Nothing's different than the other scenario. Here's where it becomes different. What happens at 6 months? You get 1/4 of 5%, but of what account? The account that doesn't have $100 in there, but it has 101, whatever 1/4 of $5, which is that's calculus. You'll learn that in calculus. All right, what that dollar amount is. So what you get is interest on interest, depending on how they compound it. Do you understand the difference at least?
Yes.
Okay, so what happens if you get it monthly? You get 5%, but you get 1/12 of 5% in your account every month. Okay, and then how many payments do you get per year? Well, in the first one, you just get one payment at the end of the year. But let's go back to the quarterly one. You get 1/4 of 5% 4 times a year. That's why K is up here as well. Do you get it? All right, now, are they majorly different? A little bit. Matter of fact, the first example that I have for this will show how the money differs depending on how you compound it. And then the other teacher, that's what I always call her. We'll just, because we don't want to use names on the internet. This is what she gave her kids, students, young adults. Fumble, wow. All right, so annually, this is why you can use this formula, by the way, because annually, what does K end up being? What's K end up being? 1. So this ends up being 1. It turns into that formula right off the bat. So that's why you really don't even need this formula. You can always use the K formula and then understand annually is 1 time a year. All right, I'm not going to go through all these because we don't have the time. I blabber too much. So that's 1 time a year. What's semi-annually? 2 times a year. We're going to see the differences between 1 time a year. I think I do monthly, and then I'm going to do something else. Quarterly. How many times is that a year? 4. Hey, get the calculator out. How many times is monthly? 12. How many times is weekly? Okay, so I don't need to how many times is daily? So this is what I mean. You would get 365 interest payments in a year, but you'd get your R divided by 365 every time. All right, so you're getting a lot more interest on interest. Now let's get nuts. What's hourly? That's why I need your calculator. 8760. That's 24 times 365, I hope, right? And then what's by the minutes?
525600.
Big. All right. So I think that was 525,000, right?
Yeah.
Here's the idea. What I'm trying to do is bridge you from here to here, and I'm not going to prove it. When K gets enormously large and actually turns into infinity, that is an infinite amount of interest payments done throughout a year, infinite amount of times, then the K formula turns into PERT. And that's kind of where E, and it's not kind of, it is where E comes from. So PERT is compounded continuously, which theoretically means you're getting compounded better than every second, even more than that. All right? And that's what you need to understand. So, not really. What you need to understand is you got to read the question. When you read the question, you got to look for the key words in it. Is it compounded annually? Is it compounded monthly? Or is it compounded continuously? So, what I did is I just took this one, and then we're going to do a solver after this. Your first beginning of 3/6 is just plug and chug. Because I already have the answer there. But what I did is I took this first example and I said, okay, let's do annually. But then let's compare how different would it be if it was compounded monthly. And then how different would it be if it was compounded continuously. So they're all getting the same percentage, 7%, but they're all being figured out in a different way. All right, so number 1, simple interest. P is principal. That's how much you put in. So P, I might as well write it, 1 plus R raised to the, they put N. I could put T. I'm just going to put N. Whatever. It's just a number or letter. And then what's 7%? I swear to gosh, if you mess this up. Because if you put 0.7, please go to a bank, and I'm going to go to your bank, and I'm going to give you my money. Oh, 7%? All right. Oh, 0.7? I'm not going to say a word, and I'll be retired in 2 years. Okay, and then raised to the what? 6. Now, very simple to type that in the calculator. By the way, 1 plus 0.07 is 1.07. You know what? You can do it. This is boring. We get this number. Let's do the other one. So that would be the answer to this question. What I want to do is, okay, wait. What would happen if I compound it monthly? What's K become? So again, 1 plus not just R divided by 12 every month. And how many interest payments do we get? Over 6 years, not 6, 12 every year. So 12 times 6. I'm trying to climb into your head how you understand this formula. Because you get an interest payment every month. So for 6 years, you get 72 interest payments. Are you with me? All right, so that's how you understand this formula. Sorry. Let's be lazy. It's 1,500 there. So this is how you can type it on your calculator. 1,500 times parentheses. I'm just going to do it. 1 plus 0.07. I don't need no fancy fractions. Divided by 12. Close that bad boy or girl. Carrots. And then 12 times 6 I can do in my head, I think. 72. Now, I bet you think this is going to be vastly different. It's not. Because it's 2280.16, which is only approximately how many dollars different than just annually? Not even 30, right? So over 6 years, that's not significant, but it is something. Now you might think, what if I did PERTs? So if I'm getting interest payments every millisecond, but better than that, I should get like $3,000 or maybe $5,000. Well, you're wrong. Because actually 12 is a lot of compounding as well. What am I doing? 1,500 E raised to the 0.07 times 6. I don't know why I put that in parentheses, but let's just move on. and not try to overanalyze it. 0.07 times 6. And that was really disappointing for the second hour. 82.94. 22.82.94. Barely a $2 plus some difference. So it's not really a big deal, but it's the usage of the formula correctly that you need to be worried about. And then last but not least, this is not 21. You do have 21 for your homework. So what I did is I changed some things so 21 acts a little different. This one's a little different because if John invests $2,300 in an account with 9% compounded monthly, that's what you have to extract out of the question. What word in there dictates what formula I need to use. How long will it take for it to go to 5,000? Well, 5,000 is the new amount. We're running out of time. 2,300 is the principal times 1 plus the rates. 0.9, I'm coming to your bank. 0.09 divided by monthly is how many times? So you get 1/12 of 9%, 12 times a year. So that's why those both go there, if that makes sense for you. But then, I don't know how long this will take, so that's the unknown. So what do I have to do in order to solve this? But not yet. What does that word or symbol or sound mean? I have to change this exponent after I clean it up into a what? You know what? I'm not even gonna round. And 23 doesn't round with 50 anyway. But what I will have to do is type this 0.09 divided by 12. 0.9, I'm going to your bank, divided by 12. Do you round this? Do you round this at all? I don't care how many spaces that goes out. You do not round that number in there. Do not do it. Okay? And then I could do the base, exponent, answer, not in the way that I circled it. So it's log base 1.0075 of 50 over 23 equals 12t. And then what am I going to have to do to solve for t at the end? Okay, I don't have a fancy calculator. I'm pretending I don't. So log of 50 over 23, close, divided by log 1.0075. You know what? I'm just going to be lazy and press enter, and then divide that answer after that by 12. T equals 8.66 what? Years. Okay, so I did all that figuring out there. So then you'll have another question that you have to use logarithms in order to solve the scenario. All right? Not a big deal, kind of a mouthful today. Oh, look, you have 3 minutes.